Hi, welcome to Math Minute. My name is Adam, and this is going to be the first video in a sequence of calculus videos. So this is going to help you through the first part of the calculus sequence. So today we're going to be talking about the derivative. Now this is going to be probably the basis of the whole class, so what's really important about calculus is getting a good strong base, especially in the derivative. So if you're having trouble so far, this is a good place to start. So first, let's start, as we are trying to build a base, let's start with something we already know. Let's talk about the slope. So the slope is the measure of the steepness of a line. Now, when we have a line such as this, we have 2 points. In this formula, we've seen a lot. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's when we have these 2 given points. In other words, this is our rise over our run. And we've seen this a lot. We've been doing a lot with this, with modeling linear functions. And so what this is just, let's make sure we understand this, because what we're going to do is no different than this. Now over here I have 2 drawings, and this is a secant line. A secant line is a function, a line that touches a function at 2 points. It intersects at 2 points. So this, we can apply this slope formula to. So we're going to start with this, and then we're going to work to a tangent line. Now what a tangent line is it touches exactly at 1 point. This is really hard to imagine, but what we want is we want this point to become this point. So as you see, I'll draw an example real quick. Let's start with a secant line such as this. Now, this isn't quite like that tangent line that we're looking for. The tangent line will look something like this, where it just touches as at 1 point. Now, what we're going to do is let's take this point and let's make it about a little bit closer. And now let's look at this line. Now do you see how much closer this line is to this? The slopes are becoming almost the same. So if we take this even closer, it becomes closer again. So what our goal is to turn this secant line into a tangent line. And we're going to use the idea of limits as this point approaches this point. So that's how we start the idea of a derivative. And what the actual derivative is the slope of this line, this dotted line that I've talked about, the tangent line. And that's really important. What it is the derivative of a function such as this, f of x, at this point is known as the slope of this tangent line. There's a few other things we call it, is the instantaneous velocity and the instantaneous rate of change. But right now, we just need to understand that we're not really doing anything too crazy. It's something that we've been doing for a while. We're just using new ideas to make these 2 points the same point. So we'll use things as limits, which we'll talk about later in the class and later in these videos, and that'll be able to help you make this point become this point. So that's been a really quick overview of the derivative, and hopefully it'll be a good base for the rest of the class. Thanks, and we'll see you next time.